Hi, guys. Today we're talking about misleading statistics, and it is the perfect time to be talking about misleading statistics because it is a political season, and politicians and other people running for office are tend to use statistics, and they can not by lying, but by changing them a little bit or showing them in a certain way try to make their point. So we have to be smarter than that, so we have to be careful about those things. Today we need to know mean, median, and mode. We did that earlier in the year, and I'm going to talk to you a little bit about an example we did in the year where somebody used truthful statistics, but they were manipulating them, making them so they weren't so meaningful. We'll do that too, and I'll give you some examples of misleading statistics. There's a book assignment and there's a super easy IXL. And on the topic of misleading statistics, we do have to be careful because we can get tricked, and there's the saying, it was caveat emptor, which is a Latin, which means let the buyer beware. There's some people who believe if we can say stuff to you, and if you're not bright enough to figure it out, then that's your own fault. So we get what we deserve. I don't think that's necessarily a great thing, but if we, as long as we're aware of things and how things can be manipulated, and we don't want to be like negative all the time, but if we look at things and saying like, hey, does that make sense? Is this something that would truly be true, or is this something that might be a little bit iffy? That we're better off, and especially in our democracy and in our civic duty, fancy term for doing what's good for the country, we need to be aware of those things and not be tricked. And people all over will use statistics, not just, they don't always do it just to be difficult or to try to get their point across, but sometimes they're like, oh yeah, we'll use this, and it doesn't always make sense. An example of that might be when you're using not enough people to use an example or to make something that's true, and this is not a statistics, but we did it on the news here in La Crosse. Really didn't cover it much, but there was a group of people, about 30 people or so. They went on Mormon Coulee Road, and they were protesting the stay-at-home order, so they were all close together. And then if they're on the news, people are like, whoa, there's 30 people here who did this, so statistically there's 30 people, that's a lot of people. In our heads, like, okay, the true statistics would be, okay, there's 30 people that are there, and they're not social distancing, which is kind of dangerous for their sake, but they're there, but they're not really talking about the 40,000 of us who are being careful. We are doing what we think is right to protect people in the society, staying home and not going out, not go to school, those types of things. So you have to be careful because it may look like something is a certain way because you see it, but you have to be very careful about what you see on the news and then what you don't see. So you don't see 40,000, 50,000 of us not there, but you do see 30,000, and you think about that. And that was the case in the Capitol too, where they went and they protested, and it was about 1,200 people or so. And there are 1,200 people who were there as opposed to, I don't know, the 3 million who weren't. And you have to kind of be careful about understanding what the point is. And I do have to say too, it just came out in the news too, that people, you have to be also careful about things too, because 72 of those people were in protests, possibly have come down with coronavirus, COVID-19. So it's the unintended thing. But just be careful for statistics. I'll show you some examples, and I'll give you your freebie for the day, and then I'll get you going on your assignment. You'll be asked to do the mean, median, and mode on this, and pretty simple. The mode is the one that shows up the most. We had done this before. The mode is the one that shows up the most. It's not the highest number. It's the number that shows up the most. The median is the middle point of all the data. So if you have to line them up from lowest to highest, find the middle one. You can count it 2, or you can count all of them and then divide by 2 and find it. And if there's 2 of them, it's the number that's halfway between those two. Then the mean is really just what we would call the average. You add up the number of numbers, add up the numbers, and then divide by the number of numbers. So if there's 10 numbers, you add up the numbers and then divide it by 10, and that will be your mean. At the beginning of the year, we had done an example when we were talking about statistics where there was a town, a city, or whatever, and they were voting for 3 people running for mayor, and each person used a different statistic to be able to prove their point. One said, oh, well, I need to be here because the people in our town typically make $0 if these were their dollars. And then another says, oh, yeah, well, I need to be because the typical amount of money they get is $100. And then one other person said, oh, no, the typical way higher than that. Most people make $3,400, and this would be a month. But you can try to decide those things. We found out that they are all telling the truth because they each used a different type of statistical measure or measure center. And they didn't say the mean was or the median was, or they didn't say the mode, they just said the typical. So on this one, the mode, again, stands for the one that shows up the most. 1, 2, 3, 4, 5. The mode is 0. Now the mean is the one where you add everything up and divide by the number of numbers. It's just like the numerical average. So I add up all these, I get 34,000. And then there's 10, so I just divide it by 10 and I get 3,400. And if this is money, that's a lot of no money, a lot of money. And then the median means the dead center one, the middle. And if I work my way in, and it's actually going to be between 0 and 100. So if you have 2 of them, it's halfway between those 2, and it's going to be $50. So you can do the mean, median, and mode with a set of data, and you can pick which one that you want to use to make a point, and it might be more misleading than others, because if you say most people in the town make $0, yeah, most people in the town do, but you can't say that the town is in trouble because the average is $0 that they make. And you have to be careful too with larger numbers like this. If you have outliers, they'll tend to make the mean go up. So if people want to try to make things seem a lot better than the situation, they might use the mean if there's an outlier in there. And the median one, usually pretty accurate, but you can mess with the things just to decide how you're going to do it. And then you can mess with the charts on how you want to show these things too. In this case, my drawings aren't perfect for this one, but it just gives you the idea. These could be the exact same data. And if I wanted to prove our economy is getting so much greater, and I show wow, it's great, or if I'm no, our economy is not improving much at all, I might use this. But if you can see the statistical trick, it's not really a statistical trick, it's just a trick with the graph. My interval is 100. So I'm going up by 100. My interval here interval is 10. So yeah, it's going to look like it's a lot bigger than this. So you can use different graphs. You can use different parts of the data to be misleading. So you just have to be careful with that. Look carefully to see what scale they are using. If you sometimes things will look exactly this, they'll be exactly the same, but boy, they can certainly look different.
Those sunflower seeds that I had, I thought they were going to be 6 feet. They're actually 7 to 12 feet that they'll grow, and I accidentally put a few of them in Jesse's garden, or vegetable garden, so they'll be really big sunflowers in there. So in the song in the background is Grateful Dead song. It's called China Cat Sunflower. It's the same guy who wrote that weird poem with the rainbow, Jingle Bell Rainbow. So your phrase today, and about the sunflowers, but your phrase today is China Cat Sunflower. It might be 12 feet tall in their garden though.
This is an example out of the book. It says an amusement park boasts, that means they're bragging about, that the average height of their roller coaster is 170 feet. Explain how this might be misleading. Now, they would say that this could be misleading because it really depends on what they use, kind of like the example that I used on the board. If they use the mean, you would add them all up, And then since there's 5 of them, divide by the number of numbers, and then find out that it's 170. The reason that's 170 is because it's higher than the other ones, because there's an outlier in there. And if there's an outlier, it's going to pull the mean and make the mean go up some. Median, if you just write it straight out, it would be 126, and then the mode would be none. I guess probably if you're talking about what is the, not necessarily average height, but the typical height of their roller coasters, probably wouldn't use 170, probably use the 126, or you could say the median height. Look at these two graphs. It's kind of funny because, oh wow, I want to say that if I'm trying to prove a point, that I might say, oh, spring dance tickets, their price has really gone up a lot, and it's an incredible amount. And then I would use the this one to prove that, because look, wow, it was here and it went way up to here. But if I wanted to prove like, oh no, it hasn't gone up much at all because here to here isn't much. If you look closely, both the same data. They've gone 2 to 4, and this is just up to 4. So it makes it look like this is bigger for amount. It's not. They're the same. They just made the graphs having a different scale. You have to be careful sometimes that graphs aren't even true. Now, if I was trying to make my point, somebody might be making their point by using this graph here, like, wow, we made up so much money. And instead of like this graph where it's like, yeah, we made some money, but it wasn't quite as much. You have to be careful. If you look very closely over here, I was trying to figure out if this didn't make sense. This goes up by 500 each time, so that's a scale. This scale goes up by 500, then all of a sudden it goes up by 100. You cannot do that. You can't change your scale in between, because then your graph doesn't make sense. If you start with a scale, whatever, if it's 100, it has to go up by 100. If it starts at 500, or you're going up by 500, it has to go up by 500. You can't go change the stuff in between. So be careful that people might just change that graph. Look carefully at the graph. It's kind of tricky on TV. I've done ones where I'll freeze them, and then I look closely. I'm like, oh my gosh, I can't believe they did that. And again, both sides do that. So hopefully you get the idea that misleading statistics, you can use mean, median, mode to do it. Different graphs, by showing if it's larger or smaller, blowing it up. There's lots of ways to make your point across. And I do want to say, not politically, I'm not trying to do the politics, but in politics, doesn't matter what side you're on. Every side uses misleading statistics to make their point, and whether that's making a chart bigger or changing kind of so it doesn't make sense but it looks like it, everybody does it. Does it necessarily mean they're lying? No. Does it mean they're kind of changing it to get their point across? Yeah. And sometimes you just have to be careful, because other times it's like, just even with anything, with advertising or anything, sometimes just a plain straight out lie. So just be careful, don't get tricked. Today, your assignment is page 817, it's 1 through 3, and page 819, 10 through 13. You do have an IXL. It kind of talks about biased and sampling, the things that we did yesterday in class. And that's 6th grade HH9. So get yourself started.